In the previous video, we saw how sound reflects off a solid surface. And echo occurs due to the reflection of sound. At the end of the last video, I told you that the distance between you and the reflection point has to be greater than 17.2 meters in order for you to hear an echo. But why should this distance be greater than this value in order to hear the repetitive sound? Let's consider that the sound wave is incident perpendicular to the surface rather than at an angle. This is just to simplify things. Here is one interesting fact. The sound that we hear persists in our mind for 0.1 second. It means the sensation of any sound that we hear lasts in our minds only for 0.1 second. How does this fact help us understand the echo? We hear an echo because the reflected sound arrived at our ear after a time greater than 0.1 second. When you clap once, you hear the sound. To hear the repetition of this sound, the time interval between the original sound and the reflected sound must be at least 0.1 second. At least means it can either be this value or greater than this value. Now we need to find out why the distance between you and the obstacle should be at least 17.2 meters for you to hear an echo. So what we will do is calculate this distance using our speed distance time formula. Let this distance be d meters. We know that the speed of sound v in air at 22 degrees is around 344 meters per second. And the time t for a wave to travel towards the wall and back is either greater than or equal to 0.1 second. So is the distance that the wave is traveling equal to d? Observe it well. In this time, the wave is covering twice the distance as it travels to this point and comes back. In 0.1 second, the sound wave is covering a distance of 2d meters. We know that the distance is the product of speed and time. In this situation, we get 2d is equal to v times t. What next? Well, we know that t is greater than or equal to 0.1 second. And v is constant. Now focus on this part. It will change to greater than or equal to 344 times 0.1. The product of these two is 34.4 meters. Now what is the term on the left? It's 2d. So we will divide both the sides by 2. Finally, we get d as greater than or equal to 17.2 meters. Hence, we say that the distance between you and the wall should be at least 17.2 meters for you to hear an echo. But wait a moment. Here the speed of sound was 344 meters per second at a temperature of 22 degrees. But what if the temperature is, say, 45 degrees Celsius? We know the speed of sound in air increases as the temperature rises. At this particular temperature, speed of sound is 358 meters per second. If we calculate the value of d now, we will get this. d is greater than or equal to 17.9. So if the temperature is 45 degrees Celsius, then we need to stand at least 17.9 meters away to hear an echo. Now let me give you another situation. If you clap in your bedroom, will you hear an echo? First of all, our bedroom is filled up with various kinds of stuff. It's not an empty space, which is one of the required conditions to hear an echo. Hence, most of the sound incident on the surfaces of these objects, including the walls, is absorbed by them. Secondly, all these things are at a distance much lesser than the minimum distance required to hear an echo. Hence, we are unable to hear multiple sounds. But what if we are in a room which is void of any objects except the 4 walls surrounding it and a roof on top of it? Will we hear an echo then? We will see that in our next video.